All right, today we're going to look at 5-4, solving special systems of linear equations. So here's what I'd like for you to do first. Go ahead and start your warm-ups. What I'd like for you to do is tell me whether the lines are parallel, coincide, which means they're the exact same line, or if they intersect. Remember, parallel, they have the same slope. Coincide, they're the same line, or intersect if they have one point. All right, hit pause. Do your warm-ups, and when you're done, go ahead and hit play and check your work. All right, if we take a look at number 1, you notice they have the same slope, so they're parallel. Now, if I simplify this, notice each one of those is divisible by 2. So I end up with x plus 3y, which means I end up with the exact same line. Here I have two different points. Close, these do not have the same slope, but these intersect at one point. Now, when this happens, certain things will happen with a. So what does this mean for systems of equations? What happens if I have two parallel lines? What happens if I have the same line? And what happens if they intersect at one point? Well, I know here my answer is going to be a coordinate. But what about these two? So a system of linear equations has one solution. It could have no solution, or it could have infinitely many solutions. Well, what does that mean? If I have two lines here and they intersect at one point, that means I'm going to have one solution. Now, if I graph a line and they have the same slope, there's going to be no solution because they'll never cross. This is when I have parallel lines. Here is when they intersect. Now, what if I draw a line? Looks like this. And when I draw my second line, I end up with one on top of the other. That's what we say they coincide. This is the same line. And if that's the case, my answer is infinitely many solutions along this point, meaning this point, this point, this point, this point, that point will all make it true. So I have infinitely many solutions. So let's take a look at what all these look like when we do the math here. So there's a couple of ways to solve this. Now, I look right here and I've got two parallel lines. So just by looking, I can tell my answer is no solution, but let's graph. So if I take a look at my first line, all right, I've got a y-intercept of 1, and then my slope is 3, so up 3 over 1, up 3 over 1. So this is my first line here. Now let's take a look at my second one. My y-intercept is negative 3, 1, 2, 3. And I've got up 3 over 1, up 3 over 1. They're really darn close together. But as you can see, I have two parallel lines. So here, if this is the case, my answer is no solution. Here, I saw the same slope, so my answer is no solution. But what happens if I solve by substitution? What does that look like? Because sometimes I can't tell right away by what it looks like. Sometimes, honestly, I really don't want to graph it. So if I were to solve this mathematically, what would it look like? All right, so I have 3x plus 1, and I'm going to substitute that for y. So I have 3x plus 1 equals 3x minus 3. So I'm going to get x to both sides. Uh-oh, those cancel out, leaving me with 1 equals negative 3. And this is not a true statement. This is false. And if I end up with a non-true statement, my answer is no solution. All right, here's what I'd like for you to do. Go ahead and do on your own 1, 2, and 3. Now, notice the directions here. You do not need to graph, but you can if you'd like. So it's up to you. So you can check for the same slope, you can substitute, you can eliminate, you can graph. However you choose to solve these, you may do so. So go ahead, hit pause. When you're done, hit play and check your work. So I have 2 parallel lines here. I also, in this case, replaced my variable, so I used substitution and ended up with no solution. When I used substitution here, I ended up with a y value and an x value, so my answer here is 4, 3. So the first 2 were no solution. Last one was a solution of 4, negative 3. Now, first off, I apologize here. This did not copy very well. So this is rectangle A, this side is 4y, and this side is 2x. This is rectangle B, this side is 12y, and this side is 6x. So the perimeter of rectangle A is 36 units. The perimeter of rectangle B is 108 units. Write and solve a system of linear equations to find the value of x and y. So if I take a look at the perimeter, so the perimeter is the outside, so that's 4y plus 4y plus 2x plus 2x equals 36. So we end up with 8y plus 4x equals 36. Now the perimeter of B, 12y plus 12y plus 6x plus 6x equals, what did we say, 108. So we end up with 24y plus 12x equals 108. So given the way these look, I can't solve them for graphing, so I'm going to solve for y. So if I take a look at A, I have 8y plus 4x equals 36. I want to solve for y, so we end up with y equals negative 4x plus 36. Divide by 8, so y equals negative 1/2 x plus 4 1/2. Now, if I look at B, I have 24y plus 12x equals 108. Oops, 108. Sorry about that. So we're going to get y by itself. So I have 24y equals negative 12x plus 108. Solve for y, dividing everything by 24. So y equals negative 1/2 x plus 4 1/2. So if I look, I can tell right now I'm going to end up with the same line. I'm going to go ahead and graph it just in case. So let's see. I have 4 1/2, 1, 2, 3, 4 1/2. And I'm going to go down 1 over 2, down 1 over 2. So this is my first line. Now, if I go to my second line, up 4 1/2, down 1 over 2, down 1 over 2. So I have the exact same line. So that means my answer here is infinitely many solutions. But if I chose not to graph that, what would it look like if I solved by elimination? So I have 8y plus 4x equals 36. 24y plus 12x equals 108. Now, I'm going to show you a little trick here that also works. Now, in the last unit, we multiplied. Here, watch what I'm going to do. I'm going to take this and I'm going to divide by 3. So this is a little bit different trick. I want to show you that there's so many different great ways to solve these equations. So 24y divided by 3, well, that's 8y. 12x divided by 3, that's 4x. And I know the sum of these digits is 9, which is divisible by 3, so I know 108 is divisible by 3, and 108 divided by 3 is 36. Now, notice I don't have any opposites. So what I'm going to do here is subtract. Remember, when you solve by elimination, you can add or subtract. Well, 8y minus 8y is 0. 4x minus 4x is 0. 36 minus 36 is, well, 0. And does 0 equal 0? Yeah, so what this means is that no matter what value I have for x and y here, as long as it's on that line, it's going to be multiple answers. So there's not just one answer. So what is my official answer then? Infinitely many solutions. However, if I look up here, it's only infinitely many solutions along this line. So any point in this line is going to give me a true statement. But this point will, and this point won't, or I'm sorry, this won't, and this won't. Anything outside of that line will not give me a true statement. So I want to be a little bit more specific here. So infinitely many solutions along the line y equals negative 1/2 x plus 4.5. So as long as it's on that line, I'm going to have a true statement. All right, go ahead and try on your own 4 and 5. Remember, you can solve these any way you would like. The graph is there if you need it, but that is just one of many fabulous options. Go ahead, hit pause. When you're done, hit play and check your work. All right, for number 4, I went ahead and used elimination because I had opposite y's here. When I did so, I got x equals 0. Careful. And then y equals 3. So for 1, I have, or for number 4, I have one solution, 0, 3. Now for number 5, when I went to use elimination for this one as well, I ended up with 0, 0, which is a true statement. Notice I have no variables left. As we're here, I did. So my answer here is infinitely many solutions along the line 1/2 x minus 5 halves. Have a great day, everybody. Be safe.